Hey! Hey! I'm Mr. O, here with another moment at the Children's Museum of Houston. In science, there are certain rules that all things must obey. There's no choice, they have to obey it. Scientists call these rules laws, the most famous of which is the law of gravity. But there are lots of other laws, including laws that describe how gases behave. As a quick reminder, gases are substances with no definite shape and no definite volume. What does this mean? Well, let's look at it like this. This is a rock, a solid. No matter what container I put it in, it keeps its shape. That's definite shape. And short of me breaking it, it will always take up the same amount of space, so it has definite volume. This is water, a liquid. When I pour it from container to container, it takes on the shape of the container, so it has no definite shape. But no matter what container I pour it into, it always takes up the same amount of space, unless I spill some. So it has definite volume. This apparently empty jar is actually filled with air, a gas. Just like liquids, it takes on the shape of its container, so it has no definite shape. However, unlike solids and liquids, gases have no definite volume. In other words, because gases have no definite volume, I can change how much space this balloon takes up without adding or removing any air. How? Simple. I follow a gas law. So this is one of the gas laws, Charles's law. No, calm down, calm down. I know it's an equation, but it's very simple to understand. The V, volume of a gas, is directly proportional to the T, temperature of a gas.
What?
In other words, as the temperature decreases, the volume of the gas decreases. And vice versa, if the temperature of the gas increases, the volume increases. So if we go back to our balloon, if we measured this balloon and stuck it in a freezer, it would get smaller, even though no air is being released. And then when we removed it from the freezer, as it warms up, it gets bigger again. So you can go test this at home with a balloon and a freezer of your own, but I have a much more dramatic way to show you. Let's put Charles's law to the test. Normally, I encourage you to try to do science at home, but liquid nitrogen is dangerous. So please, do not attempt what you're about to see at home. This is liquid nitrogen. It's cold. Very, very cold. How cold? Well, let's say this point is room temperature, about 70 degrees Fahrenheit. And this is where water freezes to form ice, 32 degrees Fahrenheit. That's a 38-degree difference. Nitrogen, which is a gas that makes up 78% of our atmosphere, is a liquid starting at negative 321 degrees Fahrenheit. That's a 391-degree difference from room temperature. Another way to think of it is that liquid nitrogen is about 10 times colder than normal ice. So if we take our balloon and put it into the liquid nitrogen, the temperature of the air inside the balloon begins to drop. As Charles's law tells us, as temperature decreases, volume decreases, so the balloon shrinks down. If we go the opposite direction and let the air in the balloon heat back up, the temperature increases, and so the volume increases. So just like people, no matter how hot or how cold a gas is, it still has to obey the law. This has been another Oh Wow moment from the Children's Museum of Houston. We hope your mind can come out to play.